and you guys never even talk. No, I just record, and it records my voice and what I write.
Hello.
No. Yeah. I know, maybe he'll be talkative now. But Reagan was watching the video the other day, and I recorded the second hour, and it was out of control. We were talking about drive-thrus, and we were talking about, I don't even know what all we were talking about, but I always run out of time in there.
But I told them that I always feel like when I'm recording that I'm like talking in a drive-thru mic, even though I know they were headsets, but in my head, a drive-thru, like you have to order in the microphone. And so whenever I'm standing here talking and the microphone's right here, I always feel it.
In a drive-thru, right? I know. It is. It's true. It gets super loud, and then I walk over there, and it gets super quiet, and you turn the volume up, and then I get back close to it, and then you're like, ah. When I'm gone, Godzilla. When I'm absent, I sometimes record notes and leave them for you to watch still, so you can't escape me. But I've learned over the years of people complaining about my voice going in and out that when I'm recording for you, like I'll record on my prep for after school, or sometimes at 2 in the morning when my kid's sick, I'll come in and record at 2 in the morning for you. But I just hold the microphone, and then I feel like Bob Barker on The Price is Right with the skinny microphone. But I just hold it like this, and I'm like walking and writing because people complain that my voice fades in and out. Then I'm gonna pull it, and I'm gonna die in a minute. But I had the little Bluetooth one I bought like for my ear, but it was just weird. I felt like Britney Spears with my little microphone. It's just awkward. So. I'm starting them already. Okay. Adding, subtracting, multiplying, and dividing functions. I did not make you write this out. I just printed it for you because you really just add, subtract, multiply, or divide functions. If you can combine like terms, you combine like terms, but a lot of times they're like two functions that you can't even add together. The big thing is when you're dividing, you have to exclude anything that can make the denominator equal 0. So we'll talk about that with domain. It says, in each case, the domain of the new function consists of all numbers that belong to both the domain of f and the domain of g. Basically, your new domain becomes like the most restrictive. So like if f is all real numbers and g is everything but 7, your new domain is now everything but 7. Right? So we'll do an example of this. All right? That's x cubed. I'm not sure if you can read that or not. So it says, if f of x is x cubed and g of x is the square root of x plus 1, find f plus g. So if I'm going to add f plus g, I'm just going to take f, which is x cubed, and I'm going to add the square root of x plus 1. Can I add any x cubed to the square root of x plus 1? Which means, guess what? That's the sum. If you could combine things together, you're going to combine them together. But in this case, you can't do anything. It does not say define the domain here, but on your homework, I know it says define the domain. So we're going to find the domain also. So the domain of x cubed is definitely all real numbers, yes? If the domain of g is all real numbers, our new domain is all real numbers. Is the domain of square root of x plus 1 all real numbers? Because you can't have a negative under your radical, right? So how can I figure out, or do you know just what the domain? What can't I have? What do you think? Can't have a negative, so what's... Do you remember what I said, how to find the domain of the square root function? Right, that 0 is the smallest you can have, so your domain of the square root function will always be if you just set that greater than or equal to 0. Because what's under the radical has to be greater than or equal to 0. And if you solve that, you will always get your domain. So for this one, we would get x is greater than or equal to negative 1. And that's true. Negative 1 plus 1 gives me 0. I can't have anything less than 0. So in interval notation, that would be starting at -1 bracket to, yes. So my new domain, when I add those together, x cubed can still be anything, but the square root of x plus 1 still can't be this. So my new domain just becomes that more restrictive one, which just becomes -1 to infinity. It could be, but I can't plug in -7 here if I can't also plug it in here. Does that make sense? Because I'm doing it all at once now. Okay. So guess what happens when I subtract them? I just subtract them. So I get x cubed minus the square root of x plus 1. Can I do anything else? No, it's that easy, right? What do you think my domain's going to be? The same thing, because I still could have anything for this, but I can't have a negative under that. So it's still -1 to infinity. When I multiply this, do you remember doing this in Algebra 2? Chapter 7, Algebra 2. I have a weird memory. So at times g, if I multiply these, I get x cubed times the square root of x plus 1. And I multiply something outside of a radical, inside of a radical. So guess what? I didn't get to leave it again. If you can multiply them, you should multiply them, but on this one you can't. Is my domain going to be the same? Yes. But the one that can have a different domain is the dividing one. So if I take f divided by g, I'm going to have x cubed divided by the square root of x plus 1. I still can't have a negative under that radical, but by putting it in the denominator, what else can't I have? I can't have 0, so what other number do I need to exclude from my domain? Just, yeah, -1 is now not included, right? What makes that go to 0 is -1. I can have it up here because I'm allowed to take the square root of 0, but I'm not allowed to divide by 0. So the one that could have a different domain is the dividing one. So it's now going to just be parentheses -1 to infinity. And definitely on your homework, they're asking you about the domains, and it's really nice that you can check them. To here, this should be a positive one. This should be, where should be a positive one? This should be a positive one? Because what makes this go to 0? Not positive, right? It's what makes that equal 0, and that's what you mean. Okay? Alright, so domain is really the only extra thing there. The real part of homework today, the good stuff, is the whole composition. You remember this? F of g of x, fog. Composition is a new operation, right? It's not multiplying. It's putting one function into another function. So when you see that little open circle, it's not multiplication. It's read f of g, and it really just means like a new set of parentheses. So like you can always replace that open circle with a set of parentheses. So f of g of x really is read f of g of x. And I always think of it as you start with the inside function and you work your way out, or you just think it's putting the inside function into the outside function. So it says given f of x is 3x squared plus 2 and g of x is 2x, find f of g. What I always do is I write it with parentheses, f of g of x. Helps me kind of see what I'm doing. And then just like if I told you to do f of 7, you know that means plug in 7 for x. I want you to plug in g of x for x. So I'm going to do it in 2 steps. I always say you can start with the inside function. So replace g of x with what g of x is, which is 2x. Okay, and g of x, is substitution there. And then I'm going to do f of 2x, which means everywhere there's an x, I'm going to replace it with 2x. So I get 3 times 2x squared plus. So I've taken G and I've plugged it into F.
Out. Yeah. Remember that composition is not commutative. So G of F and F of G are probably not going to be the same thing. G of F means we would take F, and we would plug it in right there for G. And then you just have to simplify it. Be careful. Someone today in second hour said that they would take 6 and then they would square it. That is wrong, right? Order of operations. We're going to square this first and get 4x squared plus 2. Then we multiply and get 12x squared plus 2. And that is what F of G. Questions about that? When you're talking about the domain of F of G, it's really simple if the original domains are all real numbers, because your new domain is also all real numbers. But just to kind of tell you really quickly, what you're supposed to do is you have to take into consideration the inside functions domain, which in this case is all real numbers. And you look at your new domain, which is all real numbers. And then you kind of put them together. So I tried to make up a good example so that we could look at one that's restricted differently, and it didn't really work out so well. So look on the next page, but don't start yet unless you're just waiting for a secret. I want to make it a harder question because it didn't work out so well last hour. I mean, it was too easy. So you ready for me to make it harder? What if we make this a fraction 2? Let's make this 1 over 2x. And I'm only doing this so that I can show you the domain part. Not that these show up very often, but it didn't work. Like in second hour, my domain was still just not including 4, so it didn't help anything. So, all right, so this is uglier, but f of g of x, I'm going to take g of x as 1 over x minus 4, and I'm going to plug it in to the x in the f equation. So I'm going to get 1 over 2 times 1 over x minus 4. Oh my gosh, why won't this make it a fraction? Questions on where I got that. So I took g, and I'm plugging it into my new f function that I made. I made it a fraction. This is chapter 9, algebra 2, rational equations. My favorite chapter in algebra 2. What? We did. Okay, so now I got to simplify this. So this is just like top times top, bottom times bottom. So that's just 2 over x minus 4. And then that's just minus, I'm just going to say that's 4 over 1 right now. So I want to get a common denominator. Yeah, chapter 7 we did composition, adding, subtracting. Chapter 9 you did all this fun stuff with fractions. So, I got the big 1 on the top here. If I want a common denominator, I just need to multiply this side by x minus 4. Are you with me on that? To make the common denominator of x minus 4. I'm putting this with, like, I would think, I'm putting, like, the negative up there with that 4. Does that make sense? Right. So it depends on how you look at it. But I'm trying to make it have to multiply by not so much stuff. So I'm putting my negative up at the top. So then if I have all of that as a denominator of x minus 4, this side I don't have to do anything with. So that stays a 2. This side I have to distribute, and I get minus 4x plus 16. And then I have my x minus 4. Oh, remember the complex fractions, a fraction and a fraction? I love it. I promise they're not this bad on your computer, right? I'm just trying to make a point here about domain. So, to simplify this, I would get negative 4x plus 18 all over x minus 4. What do you normally do when you have a big mess like that, besides cry? I like to think about, like, multiplying by the reciprocal, right? Like if you have a fraction, you can like invert and multiply. Any idea what I'm saying?
Like 1/2 is the same as like 1 times 3/2. That's just really 3/2. Like you change division to multiply by the reciprocal. Leave a change, flip it.
I got nothing.
2 divided by 1/5 is the same as 2 times 5/1. Right? Like when you divide by a fraction, you multiply by the reciprocal. True? True.
Yes. It is. So I'm going to just flip this over, because when I have a 1 on the top and this is on the bottom, it's just the reciprocal of it. Because that's the same as saying 1 times x minus 4 over negative 4x plus 18. Because I can multiply by the reciprocal. So I get x minus 4 over negative 4x plus 18 as my mess. Whew. That was a lot of algebra. So after all of that, what would we have to exclude from the domain of this problem? Or how can we figure out what we would have to exclude? I can't have 0 in my denominator, right? So I would have to say negative 4x plus 18 cannot equal 0. So negative 4x cannot equal negative 18 divided by negative 4. X cannot equal 9/2. True? But there's more. When you do domain of f of g, your answer, you have to take the domain of it. But you also have to exclude the domain of the inside function. Not the outside function, but the inside function. So I have to also look at this and say, oh, what can't x be in g of x? X cannot equal 4. So that carries down, and x can also not equal 4 in this domain. Does it happen very often that the domains are not all real numbers anyway, that you can't just say it's all real numbers? It doesn't happen that often, but it does happen. I wanted to address it. I put a Patrick video on the classroom site. It's like an 8-minute video, and he talks about doing the domain of compositions and its fractions. And so if you feel like I'm talking another language right now, you should maybe check out that video. We could write all this in an interval notation, but I'm not going to right now. Okay? Ooh, that was pretty. Almost. Something that you probably didn't do in Algebra 2, that we take a little step further in precalculus, is going backwards. We call it, instead of function composition, we call it function decomposition. They want you to go backwards. They say that h of x equals f of g of x. They want you to decompose this function into two functions that when you did f of g, that it would equal this function. To me, it's all about looking for like an outside function and an inside function. And my rule is you can't make one function just equal x, because that's kind of cheating. It has to be more than x. So for me, I kind of look outside and inside. So for me, under the square root looks like the inside function. So the inside function is g of x. So if I made g of x, x squared plus 5, what would f of x have to be so that when I do the composition, that I get this? Because then if I took this and I plugged it in here, I would get this. There are more than one answer. Like sometimes there's 3 or 4 different ways you can see this. But as long as the composition works, then you would get your points for it. And as long as one equation is an x. Yes. Another one that I thought of on this one is what if I made this x squared, what would f of x have to be?
square root of x plus 5, because then I could just replace that in for that, and then it would match, right? So some people are really quick at seeing these, and some people really struggle with it. So I put a few of these on your homework as well, so you can practice doing those. All right, I'm kind of out of time, so I'm not really going to get to this last one, but we can start there tomorrow. But I will tell you that this looks scary, right? They just want you to be able to solve it after y. And I promise that we'll do this one together. Like we have, you're not going to start. This is not a function. If we graph this, I'll tell you it's not a function. But we can change it back to two things we know, and if you graph them at the same time, it makes this. So you need to just solve for y. I picked a really hard one here. The ones on your homework aren't as difficult. I'll give you a hint here. I think you could factor this. What multiplies to give you x squared? What multiplies to give you y squared at the end? We want 2xy in the middle, so think about we have xy and xy. So if I just do plus and plus, that works out to give you that. I'll stop here because I want to pass out homework if you want the paper copy. But you could just take the square root of both sides, plus or minus 2, and you actually get two linear equations that actually make an x on your graph. So if you graph that equation, it makes an x, which is not a function. But that's what an implicit equation is. It's like two equations fused together. If you want a copy of the homework, I have it. Otherwise, it's on Math, Excel, or school.com. I always forget it. You want this? Oh, I'm still recording.